Welcome back, day 2, Advent of Code 2016, bathroom security. You arrive at Easter Bunny headquarters under cover of darkness. However, you left in such a rush that you forgot to use the bathroom. Fancy office buildings like this one usually have keypad locks on their bathrooms, so you search the front desk for the code. In order to improve security, the document you find says, bathroom codes will no longer be written down. Instead, please memorize and follow the procedure below to access the bathrooms. The document goes on to explain that each button to be pressed can be found by starting on the previous button and moving to adjacent buttons on the keypad. U is up, D down, L left, and R right. Each line of instructions corresponds to one button, starting at the previous button, or for the first line, the 5 button. Press whatever button you're on at the end of each line. If a move doesn't lead to a button, ignore it. You can't hold it much longer, so you decide to figure out the code as you walk to the bathroom. You picture a keyboard like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose your instructions are ULL. You start at 5 and move up to 2. So we move here, left to 1. So left moves left, and then I need to move left more, but I can't, so I stay on 1. So the first button is 1. Starting then from 1, I move right with the next instruction. So I go to 2 and then to 3 and so on. Okay, makes sense. So in this example, the bathroom code is 1985. Your puzzle input is the instructions from the document you find at the front desk. What is the bathroom code? So I have this. So it's 5 lines. Okay. Let's try this example. First, we want to read each line. For each line, we can go through each letter in that line. And yeah, we kind of start at, let's say we can use our grid, X, Y, and then position is, let's say it's 1, 1. So our grid would be, what would it be? 0, 0, 0. Wait, I have to do it like this: 0, 0, 0, 1, 0, 2. And then the next line is 1, 0, 1, 1, 1, 2. And the third line is 3, 1, 3, 1. So 3, 0, 3, 1, 3, 2. And this is this. Okay. So thinking about it this way will allow us to walk around. We start at 1, 1 and we can go left and up and so on. And then whenever we want to evaluate this, we just go to this representation. So we start at this, which is 5. And then we can say that we have a map L stays in the same row and goes back one. And R, what do we have? Yeah, R stays in the same row and goes forward one. And then map is with 2. And then we have down, goes down, but stays in the same. Vertically, up, goes up. Okay, so we have all the 4 options. Then we can just say, okay, we have a character. Let's look up in our map. Direction. Then we update our position. Direction. Or we say okay, now that we add the direction, we have to check if the new position is valid. Let's just make a new position. If dot x in 0, 2 and 0, 2. The y, x and y need to be in 0, 2. Then we update our position. And otherwise we just don't, because we walked outside of the boundaries of our grid, which is wrong here. Okay, so we have 0, 1, 2 and 0, 1, 2. So we should end up in each line at some position. Let's just run it, and then whenever we have the position, we can figure out what's the number. Position map. We just have to map all these. Two, 1, 2, 2. 2, 3. 2, 4. 2, 5. 2, 6. Give it the right amount of commas. Let's just call it position map. And then we should get some code 1985, which is this. Okay, cool. Let's get our normal input. 18843. Oops. And that's the right answer. Let's go to part 2. You finally arrive at the bathroom. It's a several-minute walk from the lobby so visitors can behold the many fancy conference rooms and water coolers on this floor. And go to punch in the code. Much to your bladder's dismay, the keypad is not at all like you imagined it. Instead, you are confronted with the result of hundreds of man-hours of bathroom keypad design meetings. So it's like this. You still start at 5 and this stop when you're at the edge and stop when you're at the edge. But given the same instructions as above, the outcome is very different. You start at, okay, that's the example. Start at 5 and don't move at all. Up and left are both edges, edging at 5. So you can't go up or left. Okay, so we have to change the way we have our grid. And we have to change the way we have our validation, whether we can move or not. I would say we can put, let's just copy this grid here. This is this. And then we have we could put seven at 0, 0, and then my 0 minus 1, 0 minus 2 for 5. Then we can put minus 1, minus 1, minus 1, 0, minus 1, 1, and here we do minus 2, 0. Maybe like this. And then we have one and minus 1, 1 and 0, 1 and 1, 1. Wait, we don't have this one. Now we just have 1 left, which is 2 and 0. So that makes it easy to check, because 1 plus 1 is 2, and 0 plus 2 is 2. 1 plus 1 is 2. Makes it easy to validate when we walk outside of the grid. So we map that to that. We have to update our position map. This is 4, so we can go here. Then we have 5, 6, 7 is 0, 0, 8, 9. Then we suddenly go to A, B, C, D. I'll just go with 10 for now. 10. actually we could go with characters. A B C D. And we have a map with proper typing from point to character. Then we go to, this is still the same. We move the same way. Our condition is different. We get this plus this must be in 0 and 2. So if we have 3, 0, then we're outside of the grid. Or even if we have 1 and 2, we're walking outside, so we're staying. And a starting position is that of 5. So let's run it. 6, 7, BB9. Yeah, BB9. And that's it. So let's look through it. For part 1, we have a grid like this, and we walk across our instructions. So I removed it now, but we can probably just go back. Can go further back. See if it works. Yeah. So we're imagining a grid like this, and we have instructions like this, so in each step we go along the grid. So we just have to map out the grid into this position map, and we start with 1, 1 being 5. And we can go to 0, 0 and to 2, 2 and all the other directions. For each line we want to walk from our current position across each character in the direction of the character, and then we update our position, but only if our new position would be valid, so it wouldn't walk out of the keypad. We can do that by staying in 0 and 2 and 0 and 2, which lets us stay in this grid from 0, 0 to 2, 2. And after each line we know the position, and based on the position we can get the number from the keypad, and that gives us the answer like this. And then it turns out that the keypad has a different structure, so that's why we had to redesign our map and our coding. So the structure has this keypad. Now we change our starting position to 0, -2. Here's 0, -2. And 0, 0 is in the middle. -2 zeros on the top, and 2 zeros at the bottom, and 0, 2 is on the side. And then this way we can also walk across it and check where is valid, and where is valid is if all of the numbers are adding up to 2. So -1 and -1, if I take the absolute value of each and add them, then they're 2. And then we have invalid, would be -1 and 2, which has absolute value of 1 is -1 is 1, absolute value of -2 is 2. So that's 3, and that's greater than 2. So that's invalid. This way we have a grid where we can easily check validity and walk across it. And then we do the same thing for each line. We go in the direction from our map. Our map is here, left, right, down, up. And then we check the new position, if it's valid, based on the new condition. We walk there. And once we have gone through all the characters in the line, we print the position. We print the value of the position in the positions map, which is a value between 1 and D, which is this. And then we get the second result. That's it for today. Thanks everyone, see you next time.